This is Kristen Codes, and I'm coding every day until I become a web developer. And my bald head is cold, so I will be snuggled in this blanket. Um, Texas is cold right now. Anyway, so on my last video, coding every day until the day 21, Advent of Code humbled me. Y'all saw how yesterday I came to some realizations after I was humbled by the first Advent of Code challenge, and people left some interesting comments, but one of the comments really stood out to me. Well, this one really stood out to me, but this one stood out as well. It said, you should definitely use AI not to do the work for you, but to help teach you. It speeds up learning greatly. It helps that productive struggle and helps you to scaffold your own learning process when you don't have an actual teacher there to guide you. Now, I have been I guess, semi putting my big toe into the pool of AI a little bit. I've been trying to stray away from it, but I have used it to create word problems, or problems, whatever. So what I did was I asked ChatGPT to look at my GitHub repositories, but it couldn't look at all of them. So then I just uploaded two JS projects from my most recent projects, which is the Advent of Code one and the password generator one. And it told me, I'm gonna share the results with you. I think this is okay. So it said refine skill assessment, solid intermediate JavaScript developer, front end focus. This project is much stronger signal of your abilities in the advent of code snippets. You're actually further along than the earlier estimate. Your level is intermediate, not beginner, not early intermediate, solid mid-level. You understand DOM manipulation, event-driven UI, object-based configuration patterns, higher order functions, random generation, custom UI logic, CSS variables via JS, clipboard API. This is advanced for most learners. I still feel like you should just be able to say document.clipboard. Whatever. I don't know. Anyway, custom pseudo framework like logic, strength meter, slider conditions. This is real front end development, not toy problems. What your code demonstrates. Let's break down the competencies your code shows. DOM mastery above typical intermediate level, strong object-based logic design, high-level algorithmic thinking, strong understanding of functions and scope, asynchronous JS, clipboard API, this function shows you're confident with async to wait, all that stuff. Intermediate to advanced skills you already showed, DOM plus CSS variable manipulation, custom UI state machine, abstraction of ASCII ranges into reusable generators, shuffle or algorithm. Not optimal, but the logic is right. It says that I'm weak in, hold on, let me move me over here. It says that I am weak. These are natural next step improvement. Needs better naming and modularity. Example, random ASCII could be more descriptive. Populate characters does too much at once. Still no ES modules, bundles, imports. Validation object exists but is unused, so little to no separation of concerns. This is normal before learning React View component architecture. Your structure is good for Vanilla.js, but you're ready to outgrow it. It's saying that I have core JavaScript, DOM manipulation, async.js, front-end UI logic architecture, tooling, React readiness. It says that I'm absolutely ready to learn React right now. It says job readiness. I didn't see this section. It says about 60% of the way you need to learn modern tooling, component architecture, React, API integration, cleaner code structure, a portfolio with 3 to 5 strong apps. Your true skill level is strong intermediate JavaScript developer. This is higher than my earlier evaluation. You are majorly ahead of where most learners are before entering React. In fact, you're already beyond DOM level courses. You should begin React by month 2, not month 3. And then I asked it to create a 6-month plan for me, which some of it was good, some of it was like, but I will be following. So to this guy, JG6213, thank you for telling me that I needed some. Where was the word that you used? Learning process helps you to scaffold. Yes, that was the word, scaffold. All right. And thus we begin our journey into the great unknown of, let's backspace, of the backspace another time. We're going to skip foundations. I already did enough of that. We're going to, no, we already, let's look at this. Custom properties, no. We already did all that. Okay, JavaScript. And after JavaScript, let's see what else. So it's JavaScript and then advanced HTML and CSS, which I already know most of this. We're gonna go from JavaScript to React, and then databases and Node.js and getting hired. So JavaScript. Let's begin. And I'm gonna read all this out loud. Let me drink some water. Introduction. JavaScript is the future of the web. More and more of the logic is making its way to the client side in order to facilitate lightning-fast user experiences. JavaScript is even moving to the server side with Node.js. That's why in this course, we'll be diving deep into it to make sure you come out with a good understanding of how it works. You've already completed the foundations course, right? Good, because now we'll be moving at warp speed into new frontiers. This section will cover a lot of ground and your brain may melt down a few times, but don't worry, that's just a flesh wound. Patch her up and keep going. When in doubt, build something. The path. Okay, so the JavaScript track. It starts with a deep look at JavaScript code organization and basic computer science concepts, finishing with a primer on creating and using a test suite for your project. We won't be focusing deeply on the really basic coding items, so it will move quickly. You should, however, already have completed the foundations course, specifically the JavaScript basics section, before starting this course. The last thing you'll do is a project which integrates everything you've learned so far in all the courses of this curriculum. This is the kind of project that you'll consider including in your portfolio as an example to demonstrate your web development skills to prospective employers. Format. There's a lot to cover, but this course has been broken up into bite-sized lessons and their accompanying projects. These projects will give you a chance to apply what you have learned and to show what you are capable of. After a few of them, you'll really start getting the hang of things. In each lesson, we will introduce the topic briefly and provide you with a list of things you should pay attention to, points to ponder. You will be asked to do readings, watch videos, do online courses or otherwise consume content to initially learn the material, and we'll be doing all of that. Every few lessons, you will be asked to build a larger project. Finally, we will include supplemental resources and other potentially useful tidbits at the end of each lesson. Enough talk. Get learning. All right, a quick review. Introduction. This course assumes that you have decent grasp on the fundamentals of JavaScript. If you just finished our foundations course, then you should skip this review and move on to the next lesson. You don't have to tell me twice. Hold on, where are we? Okay. Organizing your JavaScript code introduction. Organizing your JavaScript code. One of the most daunting parts of JavaScript is learning how to organize your code. The reason this subject can be so overwhelming is not because JavaScript is so much more complex than other languages, but because it is incredibly forgiving. Many languages force you into using specific patterns and data structures in your code, but that is not true in JavaScript. In the beginning, this is a great thing. For example, if you just want to make a button on your web page to do something, you can set that up in a couple lines of code. However, as your program becomes more complex, it can become hard to maintain unless you take care to organize your code. And because JavaScript is such a flexible language, how you do that is entirely up to you. For many coders, making decisions about design patterns is crippling. So we're here to help. This lesson series is going to cover a few of the most common design patterns that occur in modern JavaScript code. We will discuss some pros and cons of each pattern, and we'll give you a chance to practice using each pattern in a project. The patterns we'll be covering in the series are plain old JavaScript objects and object constructors, factory functions and the module pattern, classes, and ES6 modules. Going through these will give us a chance to learn about a few other important concepts in JavaScript, such as closure, prototypes, IIFEs, and more. This series covers the most important parts of JavaScript. After learning the basics of the language, are you ready? I'm ready. Objects and constructors. Okay, all right. Introduction. In our JavaScript fundamental course, you should have learned the basics of using objects to store and retrieve data. I did. Let's start with a little refresher. There are multiple ways to define objects, but in most cases, it is best to use the object literal syntax as follows. If you look at my GitHub repos, I use this syntax all the time. Okay, we have key value, property, do stuff, bam. There are also two ways to get information out of an object: dot notation and bracket notation. So there's the dot notation, my object dot property, you get the value. Bracket notation, my object, brackets, and the key name in quotations. Which method you use will depend on context. Dot notation is cleaner and is usually preferred, but there are plenty of circumstances when it is not possible to use it. For example, my object.obnoxious property won't work because that property is a string with a space in it. Likewise, you cannot use variables in dot notation. Const variable equal property. My object.variable, this gives us undefined because it's looking for a property named variable in our object, so we can't use variables in the place. But I'm pretty sure, hold on, my object variable, this is equivalent to my object property and returns a value, but we can enter an expression here. If you are feeling rusty on using objects, now might be a good time to go back and review the content in our object basics lesson from our JavaScript basics course. Lesson overview. This section contains a general overview of topics that you will learn in this lesson: how to write an object constructor and instantiate the object, describe what a prototype is and how it can be used, explain prototypal inheritance, understand the basic do's and don'ts of prototypal inheritance, explain what the this keyword is. Objects as a design pattern. One of the simplest ways you can begin to organize your code is by grouping things into objects. Take these examples from a tic-tac-toe game. So we have player 1, player 2, the player 1 marker, and the player 2 marker all in const. Then we have the player 1 object with the name Tim and the marker X, and then we have the player 2 object with the name Jen and the marker O. At first glance, the first doesn't seem so bad, and it actually takes fewer lines to write than the example using objects, but the benefits of the second approach are huge. Let me demonstrate. And the other benefit of the second approach is that when you enter that into VS Code, it gives you like these little little triangle things where you can like close that object, and then it makes everything look cleaner. Anyway, this is something that you just could not do with the example one setup. Hold on, well, let me read this. It says function print name player, console.log player.name. This is something that you could not do with the example one setup. Instead, every time you wanted to print a specific player's name, you would have to remember the correct variable name and then manually console.log it. So we would have to do console.log player1 name, console.log player2 name. Again, this isn't that bad, but what if you don't know which player's name you want to print? So function game over winning player, console.log congratulations, console.log winning player dot name plus is the winner. Or what if we aren't making a two-player game, but something more complicated, such as an online shopping site with a large inventory? In that case, using objects to keep track of an item's name, price, description, and other things is the only way to go. Unfortunately, in that type of situation, manually typing out the contents of our objects is not feasible either. We need a cleaner way to create our objects, which brings us to object constructors. This is something I have not learned yet. When you have a specific type of object that you need to duplicate, like our player or inventory items, a better way to create them is using an object constructor, which is just a regular function that by convention is named with an uppercase initial letter. It looks like this. Function player name marker, this dot name equal name, this dot marker equal marker. Oh, this is something you put inside the object, I think. And you can use it by calling the function with the keyword new. Const player. Hold on, no, you just use that function by itself. What? Const player equal new player Steve X, console.log player.name. Okay. Just like with, hold up, what if we created another one then? Oh, we named it player. What's wrong with me? We named it player. Okay, not this. Okay. Just like with objects created using the object literal method, you can add functions to the object. Function player name marker. Then we have this dot name equals name. This dot marker equals marker. I wonder if there's a way to force it into one marker or the other. This dot say name equal function console.log this name. Okay. Const player one equal new player. I like this. This is clean. This is nice. Const player one equal new player Steve X. Const player two equal new player also Steve O. Okay. Was that a reference, an MTV reference? If you know, you know. Player one dot say name Steve. Player two dot say name Steve. Safeguarding constructors. Note that as constructors are just regular functions, they could be called without using new by mistake, which would cause hard to track errors. To prevent that, you can use the new.target meta property like this. Okay. So we have the same function, the constructor. If new.target, if does not, will that return false? To prevent that, you can use the new.target meta property like this. If you must use the new operator to call the constructor. Let's look that up. Oh no. Oh. The new target meta property lets you detect whether a function or constructor was called using the new operator. In constructors and functions invoked using the new operator, new Dot target returns a reference to the constructor of function that new was called upon. In normal function calls, new dot target is undefined. Oh, so does it return true or false or something? Can I? Hold on. I just want to. Oh, hold on. So if I did something like, instead of the try catch, if I did something like const foo equal new foo equal new foo. Hold on, what? Oh. Oh. So new dot. Okay, I get it. I see. Okay. New dot target is guaranteed to be a constructible function value or undefined. Okay. All right. I got it. Understood. So we use this and we throw an error. Okay. To prevent that, you can use a meta property. Okay. Cool. Exercise. Write a constructor for making book objects. We will revisit this in the next project. Your book objects should have the book's title, author, the number of pages. Okay, so what I'm going to do is over here where you guys can't see, I'm going to create a new GitHub repo. We're going to call it Odin Practice. I hope I don't already have that. Odin Practice. Odin Practice Sessions. Create repository. Then we're gonna open open PowerShell and we're gonna clone that. Okay, then we're gonna open Visual Studio, just my favorite program in the whole wide world. And we are going to open a folder called, starts with an O, Odin Practice. All right, and in Odin Practice, we're gonna have a index.html. We're gonna have a new file, style.css. We're gonna have a script.js. We are going to go into the index. We're gonna say Odin Practice Sessions. We're gonna go to link style.css. We're gonna go to script, and it's gonna be script.js. All right, then we're gonna go here and we're going to say, actually, we don't have to do all that. We could just do body, and then we're gonna say the font is green. like the Matrix or something like that. Boop. So that's done. So now, Copilot, stop opening. Like, please. I hope there's a thing where I can change that. Then we're just gonna go in here and use strict. I think that's how we do it. I think it's just one apostrophe or whatever. And we are going to put this over here. Put that right there. So it says exercise, right? Whoop. It says exercise, write a constructor for making book objects. We will revisit this in the next project. Your book objects should have the book's title, author, the number of pages, and whether or not you have read the book. Put a function into the constructor that can report the book info like so. Okay, so from what I understand, I think it was const. Hold on, was it function book, and we want to know the title, the author, pages, and whether or not it's read or not. And then we're going to have a function. So we're going to say this dot title equals title, this dot author equals author, this dot pages equal pages. Okay, and this dot read equals read. And then we're going to have a function. And let me see, because I forgot how to do this. Okay, so we do this dot info equals function. And I don't think we need to pass anything in the function because we're already right here. So we're going to do console. Why am I writing that out? I have a thing for that. So we do, let's see how it goes. Let me just copy this. So this is the format. So we got author. This is we're not going to put that. We're just going to put title. So we're going to say this dot title by this dot author. It is that many pages long, and we are going to put this dot read if it's true, book has been read. If it's not, oh, hold on, let's put that in a book has been read. Book has not been read. All right, so we got that. Okay, so then it says it is almost always best to return things rather than putting console.log. Okay, so instead of console.log, we'll just put return. We'll just return it. Okay. All right. It is almost always best to return things rather than putting console.log directly into function. In this case, return the info string and log it after the function has been called. So what I'm going to do, I'm going to say const the Hobbit, like it says right there, equal new book, and the title is going to be The Hobbit. The Hobbit. The author is J.R.R. Tolkien. It has 295 pages, and we have not read it. It's going to be false. I forgot something right here. I wanted to do that if, I think it is new.target, and then it said throw. What kind of book is this? And so let me just do this right quick. Okay, so we're gonna, I don't know if y'all can hear that, but there's a train. Sorry for the train. I can't control the train. Okay, so we're gonna go live with this. We're going to inspect the element, go to the console, and then we're gonna try to say, how did they do it? I think they did like, they just called it. They just did they just do book? Did they just say book like that? Oh yeah, see, it did it. It's what kind? Oh yeah, so it says it right here. It says what kind of, yeah. And what if I did something like that? Title is not defined. Oh yeah. So okay. But if I do this, and then I CLG the Hobbit.info, I think that's going to be a function. Yep, see, we get The Hobbit by J.R.R. Tolkien, 295 pages. Book has not been read. We did it. We did it. This is pretty interesting. I'm going to put this is pretty interesting. All right. Let's see. Oop. Okay. It is almost best. Okay. The prototype. Before we go much further, there's something important you need to understand about JavaScript objects. All objects in JavaScript have a prototype. The prototype is another object that the original object inherits from, which is to say the original object has access to all of its prototype's methods and properties. Let's break it down. For real, let's break it down. All objects in JavaScript have a prototype. Pretty straightforward sentence here. Every object in JavaScript has a prototype. So for example, the player 1 and player 2 objects from before created with player name marker object constructor also have a prototype. Now, what does having a prototype mean? What even is a prototype of an object? Okay. The prototype is another object. This sentence also seems pretty straightforward. The prototype is just another object. Again, like the player 1 and player 2 objects, the prototype object can have properties and functions just as these player objects have properties like .name, .marker, and functions like .sayName. 3, that the original object inherits from and has access to all of its prototype's methods and properties. Here, the original object refers to an object like player 1 or player 2. These objects are said to inherit, or in other words, these objects have access to the prototype's properties or functions if they have been defined. For example, if there was a say hello function defined on the prototype, player 1 can access the function just as if it was his own function, player 1.say hello. But it's not just player 1 who can call the .say hello function, even player 2 can call it since it's defined on the prototype. Read on to know the details of how it works and how you can do this yourself. I imagine that that's probably the simplest way you can put that, because that wasn't extremely complex, but it wasn't extremely clear. But I think I understand. Accessing an object's prototype. Conceptually, you now might feel like you know, or at least have an idea of what a prototype of an object is. But how do you know or actually see what the prototype of an object is? Let's find out. You can try running the following code in the developer console of your browser. Make sure you created the player 1 and player 2 objects beforehand. You know what? I'm going to do... So object must be a base class or something, or some type of thing, just like console. And is console in blue? If I put console, nah. Anyway, object dot get prototype of the Hobbit equal. Oh, we're checking if this is the same. Okay, equals book dot prototype. No, stop it. No. Okay, let's see what we get. True. Why don't we console.log object dot get prototype of the Hobbit? Let's see. We get a constructor and we get a prototype. Length 4. 1, 2, 3, 4 arguments. Okay, so it has a lot of things. It has a lot of things. A lot. I wonder, can I say the Hobbit dot, hold on, dot object dot book dot object dot, okay. Anyway. Okay. Now to understand this code, let's use the 3 points from earlier. All objects in JavaScript have a prototype. You can check the object's prototype by using the object.getPrototypeOf function on the object, like object.getPrototypeOf player 1. The return value result of this function refers to the prototype property of the object constructor. Okay. The prototype is another object. The value of the object constructors dot prototype property contains the prototype object. The reference to this value of player.prototype is stored in every player object. Every time a player object is created. Hence, you get a true value returned when you check the object's prototype. Object.getPrototype of, so the value of the object constructors dot prototype property, player.prototype contains the prototype object. Okay. The reference to this value of player.prototype is stored in every player object every time a player object is created. Hence, you get true value returned when you check the object's prototype. 3. That the original object inherits from and has access to all of its prototype's methods and properties. As said in this earlier point, every player object has a value which refers to player.prototype. So object.getPrototype of player1 equals, well, strict equals object.getPrototype of player2 returns true. So any properties or methods defined in player.prototype will be available to the created player objects. The last sub-item needs a little bit more explanation. What does defining on the prototype mean? Consider the following code. Player.prototype.sayHello. What? Okay. Player.prototype, that is interesting. So I can just add new. Player.prototype.sayHello equal function console.log hello I'm a player. Player1.sayHello. Oh. So let's do that over here. So I could say book dot prototype dot get rating equals function this book is great. I wonder, can I do this? This dot title. Let's just start over. This dot title is a great book. Save that. Put this away, and let's say The Hobbit dot get right. Hold on. Yeah. See what that says. Oh wow. So okay. All right. Makes sense. Got it. We're tracking. The last sub-item needs a little bit more explanation. What does defining on the prototype mean? So they did player.prototype.sayHello equal function console.log hello I'm a player. Player1.sayHello logs hello I'm a player. Hello I'm a player. Okay. Here we define the sayHello function on the player.prototype object, which all the objects in which these particular player objects inherit from. It then became available for the player1 and the player2 objects to use. Similarly, you can attach other properties or functions you want to use on all player objects by defining them on the object's prototype, player.prototype. Let's read that again. It then became available for the player1 and player2 objects to use. Similarly, you can attach other properties or functions you want to use on all player objects by defining them on the object's prototype. Okay. Object.getPrototype versus proto versus prototype. Whew. Okay. Okay, so unlike what we have done so far, using object.getPrototypeOf to access an object's prototype, the same thing can also be done using dot underscore under, is that two underscores? Underscore underscore proto underscore underscore property of the object. So if I do, can I do something like the Hobbit dot proto? Why doesn't that come up? Hold on, let's erase this. Hold on, what? Oh. Why did it only put get rating? What if I do book? What? Okay, let's keep going. Unlike what we have done so far using object.getPrototypeOf to access an object's prototype, the same thing can be done using the dot proto property of the object. The same the same thing can also be done using the dot proto property of the object. However, this is a non-standard way of doing so and deprecated. Hence, it is not recommended to access an object's prototype by using this property. However, the same code can thus be rewritten. What? When I do console.log the Hobbit, it says get rating, constructor. So what if I duplicated this and said get same? Oh, it just lists the, okay. Interesting. So if I did the Hobbit, I get the same thing. Okay. All right. It says don't do this. Don't do it. In some places like legacy code, you might also come across bracket prototype bracket, which is just another way of talking about the proto property of an object like player one dot prototype. This explanation about the, so hold on, bracket notation, and then is this supposed to be an array or something? I don't know. This explanation about the prototype might have been a lot, so remember to take a breather before moving on. Prototypal inheritance. Now you may also have a question. What use is an object's prototype? What is the purpose of defining properties and functions on the prototype? Well, it looks like you can just add them whenever you want. That's cool that you can add them after the fact. We can narrow it down to two reasons. One, we can define properties and functions common among all objects on the prototype to save memory. Defining every prototype property and function takes up a lot of memory, especially if you have a lot of common properties and functions and a lot of created objects. Defining them on a centralized shared object which the objects have access to thus saves memory. The second reason is the name of this section, prototypal inheritance, which we referred to in passing earlier in the introduction to the prototype. In recap, we can say that the player 1 and player 2 objects inherit from the player.prototype object, which is from the constructor, which allows them to access functions like .sayHello. It says, now let's try to do the following. Object.getPrototypeOf. What? So we got object dot get prototype of, let's say, book dot prototype, and then we're gonna say strict equals object dot prototype. All right. True. Okay, interesting. Why don't we just go ahead and do object dot prototype? Let's go ahead and do that. Let's see what pops up. Okay. Let's leave that alone for now. So if we do the Hobbit dot value of, why isn't that popping up? Oh, it prints out. This is what I was expecting when I was doing all that prototype business, and I thought it would come out like this: book author JRO token info pages. Where are the get rating and the prototype object? Okay. Which one do we define here? The info? Info. Oh, okay. And then we put the, oh, so get rating. Okay. Okay. What's this value of function, and where did it come from if we did not define it? It comes as a result of object.getProperty of player.prototype. Having the value of object.prototype. Oh, it comes as a result of object.getPrototype of player.prototype having the value of object.prototype. This means that player.prototype is inheriting from object.prototype. So there's a main object that all the other objects inherit from. Like the constructors inherit from the base object, and then all the instances of that object inherit from all of them. It would have been nice if they would have added like an infographic. This dot value of function is defined on object dot prototype, just like dot say hello is defined on player dot prototype. This means that player dot prototype is inheriting from object dot prototype. This dot value of function is defined on object dot prototype, just like dot say hello is defined. Okay, so let's look for that. Let's look for object dot prototype, and I'm pretty sure it should be in the list, right? Value of is right here. Okay, we're learning something new every day. All right. How do we know that this dot value of function is defined on object dot prototype? We make use of another function called has on property. Okay, so we can do object that dot has. Whoa. Hold on, can we just do has on? And then we can put value of. What happens? False. It doesn't have value of, has on. Oh, yeah. Okay. How do we know that this dot value of function is defined on object? Oh. that work? True. Okay. Oh, okay. Not just the object, it's the object that, okay, it's the prototype has on property. Now, where did this dot has on property function come from? A quick check helps. Object dot prototype that has on property, true. Okay. Essentially, this is how JavaScript makes use of prototype by having the objects contain a value. To point to prototypes and inheriting from those prototypes and thus forming a chain. This kind of inheritance using prototypes is hence named as prototypal inheritance. JavaScript figures out, hold on. Could I make so there's books and then could I say horror books? Like could I create a class of horror books that inherits from books? Uh the kind of inheritance using prototypes is hence named as prototypal inheritance. JavaScript figures out which properties exist or do not exist on the object and starts traversing the chain to find the property or function like so. Is the dot value of function part of player one object? No, it is not. Remember, only the name, marker, and say name properties are part of the player objects. Is the function part of player one's prototype? Object that get property of player one value? No, only to say hello. Well, then is it a part of the object that? Well, then is it a part of the object that get prototype of player dot prototype? Oh, okay. So okay, okay. Sorry if y'all hear that in the background. My neighbors are rowdy. Okay. However, this chain does not go on forever, and if you have already tried logging the value of object.getPrototype of object.prototype, you will find that it is null, which indicates the end of the chain. And it is at the end of this chain that the specific property or function is not found. Undefined is returned. No, every prototype object inherits from object.prototype by default. Okay, so object.getPrototype of player.prototype. Get prototype of player.prototype equal object.prototype. Recommended method for prototypal inheritance. Now, how do you utilize prototypal inheritance? What do you need to do to use it? Just as we use object.getPrototype of to get or view the prototype of an object, we can use object.setPrototype of to set or mutate it. Let's see how it works by adding a person. Object constructor to the player example. Okay, so we're gonna stop right here because this is getting pretty long. It's getting an hour long, and I want to upload this. So I think tomorrow I'm gonna go through this. Well, I'm gonna start off here. It's gonna probably be like a 2 hour, hour and 30 minute video, something like that. But I'm gonna stop right here, and on my own, I'm gonna do Jonas's course a little bit. All right, so that's day one of the Odin Project. So I want to thank everybody for watching this. Thank you for listening to me. Thank you for studying with me. Thank you for having me on in the background. Thank you for subscribing. There's 1,000 subscribers now. That's really incredible. I appreciate y'all watching me, and I appreciate y'all going on this journey with me. I will see you guys tomorrow, probably a little bit earlier. Okay. Have a wonderful day, and If y'all want to put stuff about prototypes and inheritance in the comments, go ahead. I will talk to y'all later. Bye bye.